Coders, welcome back. Today we're going to hoist some creative coding. We're diving into Three.js RayCasting, lights with shadows, and subsurface shading to create a dazzling interactive art surface. Monstrous tutorial incoming. Will you learn it? Let's start now. Okay, starting from here, we're going to build this beautiful interactive cube surface. Some things that we're going to learn about on the way today is how to cast shadows, how to get this really cool color effect, the use of this subsurface scattering shader, and what else? Mouse interactivity using RayCasting. Let's get started. I want to create a reusable method that'll get me a box. So let's call it getBox, and ultimately I'm creating a grid, so it's gonna take a column, a row, the size of the box, and then the total number of columns and the total number of rows. And it's gonna return that box. The box is gonna be inside of a group or an object 3D. And hang on, let's talk about the placement of it first. I'll calculate the start position, like so, and then calculate the box position using that start position. Here's that object 3D, and this depth property, which I'll use for the mesh later. I'm going to set its position. Now I'm going to add a mesh to that object. Right now there's nothing renderable in there at all, but now I've got this box geometry, and I'm going to add a unique color based on its position. I'm going to calculate the hue doing a linear interpolation, excuse me. This lerp is a linear interpolation between these two values of hue based on the column and the total number of columns. And I'll create a new color and set its hue thus, and then use that as the color for my material. Then add that mesh to the object that I created, the object 3D. Let's add edges as well to define like just the border of those. You could just use a wireframe geometry, but that's going to give you those diagonal lines that represent the triangles on every face. And to avoid that, I'm just going to use edges geometry, and you pass in this threshold to define which edges to show and which not to show. This is a group of variables I'm going to use in the update method. Because I want to animate, well, we'll get to that in a second. Let me just add the update method. Once we've set up the RayCasting and the mouse interaction, I'm going to, in the update method, continually calculate the distance between the mouse position and this mesh. And if that distance is underneath a certain threshold, in this case 5, then I'm going to set the goal position, the goal Z position, to be this value, which is 5 minus the distance. So in the middle, it'll be the most, 5 minus 0 in the middle. And then as it grows distant from the mouse, that value will decrease. And then just multiply it, like amplify it, and give it a random offset as well. There's a random offset. If we're not under the threshold, then the goal position is 0. This is an interpolation. We're transitioning between these values at this rate every frame. And I just want to add that to the scene, and there we see it. The update method's not going to work yet because I don't have the interactivity set up. Okay, the next step is to create a composition. To do that, I'm going to use a method called createComposition. And it's going to return a 3.group, and this is how you call it and use it. Just create a group and return it, but we want to, that's actually not needed, but I'll leave it there for now. Here's an update method that I'm going to call once this is all in place. And this array, helper array, which you'll see will be useful in a second. There's the parameters of my grid. 32 by 32 with a max box size of 12 and a noise scale of 0.025 and a we're going to add noise in a second. I'm just going to create a for loop that loops over every position, but it just grabs a random value for a column and a random value for a row. And then I'm going to set the size of the box based on this noise value that I pull out. Check out my other videos on noise for more details about how that noise works. Then, so I define a random size based on that noise and place the box. Let's look what place box looks. Let's look at what place box looks like. I'm going to set the props, get a box, and say it's ready to add is true. But before I add it, I'm going to check if it's out of bounds using some helper methods that I've written. And if it's not out of bounds, check every other box if it's overlapping. Also another helper method. And ultimately, if it passes those tests and you can add it, add it to this helper array, which I used here, and add it to the group as well. Then, after I've randomly added boxes of all sizes, I want to make sure that all the spaces left over get filled up as well. So I'll do the same, but now each box size is just 1. Okay, I want to make sure to import my helper functions and instantiate the improved noise. Also import that. And I think, whoops. Set the camera position back. Hang on, I think I've gone far enough. Yeah, let's scooch the camera position back so we can see everything. And there you have it. How beautiful is that? The next thing we'll do is to add interactivity to this. I'll put a big plane on the screen at the mouse. I'll use a RayCaster to find at which point in that plane the mouse is. And then based on that position, I'll animate the boxes closest to that. And the way we're going to do that is to lay an invisible plane down in our scene right along the face of this grid layout, and then add a mouse listener so that we track the position of the mouse and cast a ray from that point where the mouse is through the scene. And if it intersects our plane, we grab that point and we use that as a basis for interacting with this grid. If a box is within a certain range of that point, we can have it do something. In this case, we'll have it slide out on the Z axis. Here's where I want to add the interactivity. So, let's create const RayCaster equals a new Three.js, and I'm going to need a pointer pos, I'm going to call it. It's not a vector 2, it's a vector 3, and it's at 0, 0. And I'll need the mouse pos. Const mouse pos equals a new vector 3. I think I was toying around with placing it somewhere off screen. I'm just going to leave it at 0 though. Great. It looks like we're already using mouse pos up here in our update method for each get box to calculate this distance. That's great. The next thing is to handle mouse move. So window.add event listener, and we'll call mouse move. Great. And then we'll set the position of pointer pos based on the position of the mouse in the browser divided by the inner height, so that this will give us a value between 0 and 1, I think. I'm not really sure, but it seems to work pretty well this way. So just do it this way. Great. Now we're handling the mouse movement and we're setting the pointer pos. We want to add a method here, handle RayCast. Okay. And I don't like this light being here. I'm going to move it. Great. So this is what that function looks like. Function handle raycast. Set from camera is the method we'll use. We use that coordinate, that vector 2, and we pass in the camera. And from that, we pull out the intersects. All the objects in this array that the raycaster interacts with. And this boxes, as you recall, is our composition. That's almost right. What I think I want it to be. Actually, I don't want it to be boxes. I want it to be, let's call this the mouse plane, which we have yet to define. And here we copy that point into our mouse paws. Is that going to work though? Hang on. I guess so. I guess it will work. So let's define this mouse plane here. Const mouse plane geo is equal to a new 3.plane geometry, 48 by 48 by 48 by 48 by 48. And the mouse plane mat is just this invisible material, which won't be invisible yet. But let's set it to wireframe too. Wireframe is true, like so. And const mouse plane equals a new mesh, scene.add mouse plane. Oh, look at that. I love it. Now we make it transparent. I'm actually going to leave it semi-transparent. Okay. And let's log out that value in the handle raycast. I'm going to say console.log mouse paws, and then we can see it updating as we move around. Okay. Yay. Now that we have mouse paws, let's update our animate method to say boxes.userdata.update, and we'll pass in t. Do I even need t? I don't think I do. Boxes is defined up here. Just make sure this method is calling all of them. Not really caring about that right now. Update t. Don't even need that. Just call it. Let's see if it works. Oh, it does. It just works. Let's get rid of this. There you go. We got this beautiful interactivity. We can change the threshold. This here, if we make it tiny, only a small portion will be interactive as we move around. And conversely, if we made it enormous, oh boy, that's really bad. The whole thing kind of undulates around, which is also a cool effect. Let's put it back at 5, because I think 5 is kind of nice. And also, let's hide that grid now. We don't need to see the mouse grid. And clean this up, like so. Well, that worked out nice. The last thing to do is to add the lighting and the shadows. Is that really right? And then we can talk about some of the variations we can do and things you could play with yourself. Actually, you can play with any of this stuff, but some ideas for playing with stuff. Lights. In addition to these methods here, I've added a sunlight. Let's call it get sunlight. And the reason it lives in here in libs is because of all this kind of boilerplate that goes along with that light. Typically, you just create a directional light and add it to the scene. But in this case, I wanted to cast shadows, so I'm adding all of these definitions, the near, the far, all designed to make the shadows work properly on this. So we got that. Get sunlight. Let's add that. I'm going to blow away that hemisphere light and just add this instead. Whoops. Not sure I love this keyboard. Yep, and then scene.add sunlight. Let's see how that looks. Oh, it's so bright. It's positioned exactly where I want it to, but oh my god, that's not good. And you'll notice there's no shadows either. So there's a step you need to do to the renderer in order to enable shadows. Renderer dot enable. What's it called? I thought it was enable. Enable damping. Shadow. Oh, is it shadow map dot enabled equals true? Wow, that's kind of odd. That's fine, but none of these guys are casting or receiving shadows yet. Let's change that. Oh, look at the shadows. Isn't that cool? Because I'm using this material, the colors are kind of blown out. If I go to my lib, modify get sunlight so that the intensity is a lot lower, like 5, that's a little better. Let's drop it down to 1. That's better. Look at those shadows. Aren't those nice? Let's add in that subsurface material and then wrap it up. I'm going to comment out this plain old mesh and add the SSS material, which I didn't import. So get it. Get SSS material. There. Oh, it's just really dark. That actually looks really cool too, though. Doesn't that look cool? Let's turn up sunlight again. I think it was at 50. Yeah. But I'm not getting that nice glowy effect. Let's add in a couple more lights. A spotlight on the left and a spotlight on the right. Add a spotlight on the right side. And look at that beautiful glowy. It's a purple light. But actually it doesn't matter what color it is. Well, it kind of matters. And let's add one on the left side as well. And you get that. Without these spotlights, we don't get that glowiness, and all the shadows are just pitch black. I'm curious what a hemisphere light looks like. Const hemi light equals a new hemisphere light. The shadows still look black. It's unremarkable. Maybe it's because it's so dim. Let's crank it up to 5. No, that's no good. 50. Make it white. Yeah, no, this hemisphere light is useless, but these spotlights add a lot of juiciness to this. I think it would be fun. By the way, that's it. We pretty much covered all of the stuff I wanted to cover in this. But I encourage you to play around with this and experiment. I want to start with the color, experimenting with the color. Here in get box, I'm defining the hue. I could call this start hue and end hue, or left hue and right hue. Const start hue equals that, and end hue equals that. Isn't that cool? Or math.random and math.random. Whoops. That's not exactly what I was expecting. Love it. I love it. Let's pull these guys out of here. put them up top so they're only reset once you reload. Whoops. Wow, so rainbowy. You could also set the spotlights to match these random hues, but I'm not going to do that right now. Or if you find one you really like, let's console.log start hue and end hue. Let's say I love this one. Just grab those values. I'm going to say 0.2. Just to round it to that value, and the second one is 0.8. Like that, you could just grab them. Oh, that's a little off actually. 0.68 is what I meant to do. 6 or 0.7. Oh my God, isn't that nice? Thanks so much for tuning in and enjoying this lesson with me. I sure enjoyed it. I encourage you to check this code out of the repo, download it, and play around with some of these values, like the colors. You could play around with the interactivity. Right now I'm setting the Z position, but why not do something crazy? Rotation. Just change this to rotation and see what happens. Okay, that's kind of crazy. But I think you get the idea. Scale. Scale. That's not really working. Scale's not working so good. I mean, it's kind of affecting the color. What I would do instead, let's see. Let's put these back to position. I think it would be something like this. Object.scale.set scalar, and then pass in the position Z. Let's see what happens then. So they're kind of scaling up too, moving and scaling. Just, I kind of want to just have the scaling. I like this, the moving and scaling though. Thanks for tuning in. As always, leave a comment below with your suggestions, and if you have any questions or any criticisms, I'd like to hear all of it. Please consider supporting me over on Patreon. I love making these videos. Your support makes it possible to make more and more of these and devote more time to this, and they get better and better. So that would be awesome. Thank you.